Hi guys. Today we're going to learn about the electric force, otherwise known as Coulomb's law. You remember charge, that quantity called charge that electrons have, protons have, is measured in coulombs. And of course, if we have two positives, they will feel a force repelling each other. Two negatives, also a force repelling each other, and of course, to complete the picture, if we have opposites, they attract. So, of course, likes repel, opposites attract. So this, of course, is determining the direction of the force on each of these objects, each of these charges, but it does not tell us the quantity. So the quantity is determined by Coulomb's law, which is similar to the gravitational law. You hopefully remember that if there are two masses, call them little m and big M, separated by a distance r. So once again, we could use the distance d here, but I'm going to use r, because typically these are orbits of a radius r. Doesn't matter. We could call it x, y, squiggle. You can always label a variable, whatever you please. I think we'll call it r. Then the gravitational force that each of them experience, which of course will be equal and opposite due to Newton's third law, is given by the equation gmm over r squared. So notice how it depends on the masses and the distance between them. But look, it's what's called an inverse square law. What does that mean? Inverse means inverse, of course, means if the distance increases, the force decreases. It gets weaker the farther away and stronger the closer you are. You can think of a black hole having almost zero radius and therefore infinite gravity. And square, of course, meaning you square the distance, meaning if the distance doubles, it goes down by a factor of 4. The Coulomb's law is very similar, where if we have two charges, little q and big Q, separated by a distance r, then the force between them will be given by this equation. So notice how the big difference between the electric force and the gravitational force is that the electric force depends on charge, the gravitational force depends on mass. And of course we have a different constant proportionality. So this is called the electric constant and has a value of 9 times 10 to the negative 9. The gravitational constant, just for reference, you don't need to know these numbers, but it's good to know them. 6.67 times 10 to the negative 11. So that tells you how much stronger electricity is than gravity. So notice how they both have the inverse square law. So this is the quantity value, quantity of the charge. So by the way, this is extraordinarily important. You never, ever, ever want to plug in negative signs into this equation. I will put absolute value signs there because this is quantity only. So you only get a number, meaning you only get the magnitude, quantity otherwise known as magnitude. So this is the direction of the vector given by opposites attract and likes repel, and the magnitude of the vector is given by this equation. I hope that makes sense. You can do a little example down here of two charges. Say we have a 1 coulomb, positive 1 coulomb, and we have a negative 1 coulomb charge. They will clearly attract each other, and we can plug numbers in to figure it out, but let's do a proportion question. Let's say they're separated by 10 centimeters. And the force is just some general F. Obviously we could figure it out, but I don't feel like doing that. I just want to ask this question. I want to ask, what happens if I separate them by 30 centimeters? What is the new force in terms of F? Take a second. Hopefully you see that the distance, which I'm calling r, I know it might be uncomfortable to call distance r, but it's okay. R will triple. Which means the force goes down by a factor of 9. So you'd say this force here was F over 9. So if these are both experiencing a force F, these will now experience a force F over 9. I hope that makes sense. Stay tuned to the next video. I'll do a calculation example.